Okay, cool. Apologies for being late, folks. I was actually at stage 3, which is over there, not the proper stage 3 that I'm supposed to be at here. Fortunately, I talk really fast, and I will stay away from that speaker. Fortunately, I talk really fast, so I think we'll still be able to get through this in time. Okay, my intention this morning is to step through the evolution of AI and automotive interfaces to kind of set a stage for how we have evolved our interfaces to create a huge amount of cognitive load. I'll explain what that is. And then I wanted to discuss using interaction modalities that are outside of a touchscreen, which can help solve some of the issues that are presented by cognitive load. And finally, what I want to take you to come away from this presentation with is the concept of no UI. And we're going to go through this quite a bit in this presentation, so I'm just going to set up the tenets right now, and we'll go through these in detail later in the presentation. So the first, I'm just going to read through these really quick so you know them. We're not going to spend a lot of time. The first key tenet of no UI is respectful expectation setting. The next one is shift from interaction to intention. The next one is move from being proactive, be proactive and predictive. And then the last one is invisible operation with effective error recovery. So we'll go through these quite a bit in detail. So let's go ahead and start at the beginning. This is the basically first car that was ever presented. This is the 1885 Benz patent motor wagon, and I want to talk about how you controlled this vehicle. And remember, this is the first horseless carriage, so we'll see that the mechanisms for controlling this vehicle really came from kind of how you would control a horse. In this case, instead of having a steering wheel, you had this mechanical tiller that you moved back and forth to control how you were steering. And then you had this lever. You didn't exactly stop or accelerate, you kind of control the momentum back and forth, just as you might with a horse. I feel like this microphone just went out. You can still hear me? I will just keep going. Pretty quiet. Okay, so we'll move on now to the Ford Model T. So we're in 1915, and you can see that some of the control mechanisms are starting to evolve now to something that we might expect more likely. It now has a steering wheel instead of that tiller, and it even has pedals. But the interesting thing about these pedals is they're used to shift the gears. They're not used for stopping and starting like you might expect. There's actually a lever on the steering wheel for accelerating. So we're starting to approach what we might expect in modern cars. And there really aren't many gauges to look at here. Basically, there's no speedometer. You aren't going that fast. The only gauge that you really need to monitor is your oil pressure. So now we're moving into the modern convention of cars. This isn't the first car that had our modern instrumentation specification, but it's just a really pretty one. And what I wanted to highlight on this one was their Uniscope instrument pod. So this is that center instrument pod that has all your important gauges and stuff in there. Really super central and user-centric. The other interesting thing about this is that I feel like I'm just yelling out to you in general. I don't think this is doing anything. Great. Thank you for letting me know that. The other thing that's interesting about this vehicle is this vehicle now has climate controls. So now we're starting to get out of controls that are not necessarily just steering and operating the car. We now have accessories and other things that we need to manage. Okay, so let's fast forward to this 1972 Maserati Boomerang concept car. The Italians were trying to do some really amazing stuff here by creating a really central pod where all the controls and mechanisms are in that central pod, and then the steering wheel rotates around that. It's a pretty innovative idea and pretty cool, but it was just a concept car, and it never made it into production. So obviously it wasn't that great of an idea because it never really materialized, since it's something that we are using today. But if we look on the other side of the pond, in the same time frame, this is just 4 years later, The Citroën Visa actually created a lot of these same control mechanisms. The interesting thing about this one is it has two main pods that the user, the driver, uses to control the mechanisms. On the left are all the climate control, your lighting control, and your turn signals. And then on the right are your heating controls and other things. So this is a really interesting UI because I think it is really user-centric. But there are quite a lot of problems with this. For instance, what are you going to do if your passenger wants to change the temperature? It becomes difficult. So that pattern didn't emerge for last for very long. So the next thing I want to do is talk about a few interesting innovations that came in automobiles in 1984. So the 1984 Chrysler LeBaron, this was quite the hotness. And what it presented, this is the first car that talked back to you. This had electronic voice assist, this magic thing that would tell you all sorts of things about your car. The problem is that it didn't tell you the right things, or it was super obnoxious and annoying. So it might tell you that your windshield wipers are out of fluid when you have plenty of fluid and really your oil pressure is low. Besides that, the notifications were really loud and annoying. So let's do a quick demo and see if you can kind of hear. And as you see the demo, you'll quickly discover why this technology didn't last very long. Looks like my demos are not, oh, there it is. If it doesn't work, we'll just move on. It's only a 30-second demo. I do have this presentation downloaded too for offline mode, so I don't know why that's not working, but that's okay. You'll just have to trust me. It was really annoying. Okay, so I wanted to move on now to the 1986 Buick Riviera. This was the first vehicle that had a graphic control center. So this is a 9-inch CRT touchscreen that had 91 functions and an audible touch with each beep. This was a super problematic user interface because it required the driver to take their eyes off the road almost continuously. The driver could no longer use memory to remember where their radio buttons are. Let's talk about what this is replacing. So the previous radio in this car had 6 physical buttons on the bottom that you use for all your favorite radio stations, and you would just click through those to quickly go through to find the music that you liked. And that was obviously something did all the time, and you could do that by memory. You didn't have to take your eyes off the road. You didn't have to know anything. You can see that this touchscreen is quite a bit different. It is not easy to see, and it is extremely difficult to remember where you're touching and other issues. So let's talk real quick about some of the challenges that touchscreens present and the cognitive load that results in them. As I mentioned, this is replacing physical buttons where the user could remember everything. There's no haptic feedback anymore on a touchscreen. You don't always know if you're properly pressing the button or if the button you're pressing is the right one. The driver attention is taken away from the road. The driver now has to look at the touchscreen, search through all the different menus to find the things that they really want. This results in a super high cognitive load that impacts the driver attention and takes their focus off the road and onto using the interface, which is not something we want. The loss of haptic feedback from the physical response from those buttons increased visual demand. The user now has to look to see what they're touching and maybe even look to see if the button they pressed actually responded as they expected. So these complex menus buried a lot of really important information that we need. Basically, what Hollywood has been sharing with us for all these years is that the touchscreen UIs are going to be the magic and they're going to be everything that we ever wanted. But the fact is, these touchscreens are not what we want. We wanted jetpacks, and they didn't deliver those. Okay, so I've spent a lot of time now, hopefully, explaining some sources of cognitive load and highlighting some of the sources of cognitive load that have evolved when driving a car. So let's just define what cognitive load is real quick, and then we can dig into ways where we're going to try to manage that. So the definition of cognitive load is something that arises from the way information is presented or from unnecessary interactions that don't contribute to the task at hand. All right, so let's step into the modern vehicle. This is a 2024 Cadillac Lyriq that I rented for Google I/O this year. Some of the features of this vehicle are it has a large 33-inch diagonal LED touchscreen display, right? You see that big touchscreen that spans all across the user's interface. Also has Super Cruise, which is, automated driving. It has choreographed lighting effects so that when you do stuff, the car changes colors and, does things to respond. It includes a lot of safety features like front pedestrian braking, lane keep assist, and a lot of other things. And of course, it includes Android Auto and Apple CarPlay, which is great. However, this vehicle is full of cognitive load. And let's talk about some of the big sources of cognitive load that are present in this Cadillac Lyriq. The first one is information clutter. That 33-inch LED screen has a lot of information on it, including multiple touchscreens that can be configured in all sorts of different ways. And I don't necessarily know where the information that I'm looking for is. The steering wheel has multiple buttons on it. The top buttons are clicky buttons that when you press them, they do something. The bottom buttons are just touch-sensitive buttons that don't do anything when you press them. And those are actually, it took me about 3 days to figure this out, but that's actually the button that fast-forwarded and reverses your song, which is pretty important. There's no haptic feedback on that at all. I press the button, I don't know that it's been pressed. It's super difficult. So that's not enough haptic feedback. There's also too much haptic feedback. So this vehicle actually has a driver's seat that vibrates. Vibrates sometimes when I have my turn signal on and there's someone in my blind spot. Super great, and I like that. However, it also vibrates all sorts of other times. It vibrated when I was pulling into a parking spot. It didn't stop. It vibrated when I was pulling out of a parking spot. It vibrated just when it seemed like, it felt like it wanted to. So instead of being a super actionable, useful signal, it became noise. If I own this car, the seat haptic feedback would be the first thing I disable. And if there isn't a way to do that in the menu system, I would do it with a pair of wire clippers. And then the last source of high cognitive feedback is the menu overload in this system, in this car. There are buttons and touchscreens and control mechanisms all over this vehicle. There are 2 touchscreens on the right and the left of the driver. The steering wheel has all sorts of buttons. There's all sorts of buttons on the dash, and it even has a rotating controller there on the handle. They all do the same things. They all access the same menus, but if you're not, cognizant of what this vehicle does, it's incredible cognitive overload, and it creates lots of problems. Some things that I can't mention in this that also cause cognitive overload are auditory overload. There's lots of beeps and notifications in this car that I didn't know what they meant and I didn't know what they were doing. Voice command failures can be a big problem. If you ask the car to do something and it doesn't respond or it does something incorrectly, that's extremely difficult and creates a high cognitive load for the user. And finally, the biggest cognitive load for a driver is actually driving. We want the driver to have their eyes on the road, be looking at all the other vehicles around, not fiddling with buttons and trying to figure out how to get the heat turned down. Okay, so hopefully the beginning of this presentation has set the stage very clearly that cognitive load is bad for user experience. For one thing, it can increase errors. Users are far more likely to make mistakes or miss important details when the options aren't clearly marked or they have to go through complex menus to accomplish stuff. Slows down task completion. Any of these cognitive load issues create mental friction, which is bad for the user. Every unnecessary action or element forces the user to stop, to think, and to process what they're doing, which turns quick UI interactions into difficult, strained efforts. It hinders learning adoption. If we have a high load interface that is difficult to understand, it's also difficult to learn and remember. Users will struggle to become proficient with the UI because they don't understand how it's functioning. So these sort of bad user experiences cause frustration and abandonment. Users feel stressed and incompetent when the interface is not clear, and this is a primary reason. This is a primary reason why users abandon products. And finally, and maybe most important, is poor user interfaces that are difficult to understand leave the user feeling that the product is unpredictable and unreliable. This erodes the user's trust in the product and the brands that are presenting that product. So let's talk about some sources of cognitive load, and I hope that image that I presented hits pretty good for this crowd, because I definitely wanted to leave that image up there. Before we get started, the interesting thing about this image, which I believe demonstrates high cognitive load, is that is an image that Apple chose to share about this product specifically, which I don't understand. But anyway, let's talk about some sources of cognitive load that you should all be thinking about when you are developing products so that you can avoid them. The first one is choice overload, presenting too many options or features at once, leading to decision fatigue. Visual clutter and poor hierarchy, dense layouts with no clear focal points cause users to hunt for information, which is not a good user experience. Ambiguity, leaving users with unclear icons or jargon or labels, make the user guess what the action does and does not create confidence in the user. Inconsistent design is difficult because if you change the placement, style, or function of common elements, the user is not familiar with that use case and feels uncomfortable, and it takes them out of their common element. Poor readability, pause, low contrast text or indistinguishable colors, overly small font sizes, or anything that requires straining to read is bad for the user. Forcing user memory, so requiring the users to remember how a product works or where an image or where an icon is presented is not good user interface and should be avoided. And then finally, any source of unnecessary friction. Adding extra steps, clicks, or forms to complete a simple common task is bad user interface. So we definitely know now some of the sources of cognitive load and that it's bad for the user. It would be a bad presentation if I didn't present you with some ways to actually manage that to move forward and make your lives and your users' experiences better. And for this, I want to focus on what I was presenting earlier in the presentation on No UI. We are going to use No UI to reduce cognitive load and present a better user experience. So I'm not going to go too much deeply into these specific things right now in the interest of time, but I'm going to dig really deep into an example to show how this manifests itself in our modern user interface. So again, these are the key tenets of No UI, and I'm going to use an example now to demonstrate each of these as we go through a specific use case example. So the example I want to demonstrate is this future use case of a person ordering up a automated self-driving vehicle to take them to a meeting. You'll notice that when the person comes up to the car recognizes them, opens the door for them automatically, and also presents them that hamburger, which it notices that it's lunchtime, that the passenger likes hamburgers, and that there's a restaurant on the way that serves hamburgers. So it presented all that to that person automatically, so that the person really didn't have to think about anything in this interaction. All they had to do was walk up to the vehicle and get in, and everything else was taken care of for them. So let's talk about how this works. So the respectful expectation setting, this is for tasks with a delayed result. The interface avoids vague processing, feedback, or other output, and clearly sets the expectation for when the result should be expected. So in this case, instead of a constantly loading spinner or something, the person ahead of time would have known your car is coming, you should expect it in 5 minutes, and maybe see a countdown, just like we see in Uber. So they know what to expect, and the vehicle itself has given them the expectation of what's coming. We're not going to keep presenting them with a message every 30 seconds. Hey, your car's on the way. It's going to be there in 2 minutes and 15 seconds. Now it's going to be there in 2 minutes. We set the expectation early, and then we leave the user alone because they know what to expect. The next example I want to talk about is shift from interaction to intention. In this case, we want to understand the user's ultimate goal, which is their intent, rather than requiring them to perform a series of steps, which is the interaction. So this one is really good to demonstrate on this particular use case. The user's intention in this case was, I want to get in the vehicle and go. The system understood that intent from the user's proximity, maybe a camera that it recognized her coming up, or a variety of other things. And instead of requiring the users to maybe press a button in their phone, or reach for a car key and press a fob, or even press a button on the vehicle knew what her intent was. It recognized her. It opened the vehicle to let her in. There was nothing there that she had to interact with, and there was no particular interaction that we required of her. Super cool. So the next one is that no UI systems anticipate users' need based on context, history, and environmental cues, acting without being explicitly prompted. So the example of the vehicle presenting the hamburger and the option for the lady to stop and get some lunch before her next meeting, that's all predictive and proactive. It knew based on the time of day, maybe the context of this user's previous stops, and the other things that it may want to present this user with the option to get lunch. And of course, the user had the option to take that or not. You're not, locked into that particular experience if you don't want it. But it's all there for you, and the user isn't required. We're not requiring the user to do anything. This is all new, no UI, where the systems we're presenting and we're creating handle all of this. We're not requiring the user to do anything other than be there and be present and have the proper intentions. Okay, the outcome is the interface is the next one. The successful result of an action serves as its own confirmation, eliminating the need for explicit feedback. So in this case, as the lady walked up to the vehicle and the door opened up, that's all we needed to see. The lady knew that the car recognizes her, and the car then confirms, hey, I gotcha, the vehicle's opening up. Another really good example of this is when you ask your home automation system to turn the light on. It doesn't respond back, hey, Mike, I turned the light on for you. Can you see that it's on now? Look, it's bright. The light just turns on, and you know the AI got it. Cool. We don't need all this extra cognitive load because the user knows what's happening. And then the last one that isn't as easy to quite demonstrate in a use case is that the AI should operate in the background, fading into invisibility. It should only surface when necessary to resolve ambiguity or request a critical decision. So maybe in this case, requesting a critical decision is asking the woman if she wants to go get a hamburger. it doesn't necessarily know if that's a decision. It can't make that decision for her. But let's talk about some things that might have happened before the lady walked up to the vehicle. Maybe a bunch of other people walked up to the vehicle first that even looked a lot like her. But the vehicle went through the error and went through the necessary steps to make sure that it's not opening the door for the wrong person, maybe based on finding the person's Bluetooth signal or who knows what. But it's going to handle all that stuff in the background. It's not going to present the user with any sort of issues until it's really necessary. Handle all the errors and all the problems in the background so you can just present the user with the confirmation that the action was completed. Okay, so we're pulling into the end of the presentation, and I wanted to highlight a actual real-world example, which I don't think is going to work because the video is not going to show. But I live in Phoenix, Arizona, where we have Waymo vehicles. So this is exactly the thing that we are demonstrating. And the Waymo vehicle does an excellent job of reducing cognitive load. It does all the things that I just said. And if I can get the video to work, I will step through the steps of how that how the different no UI tenets are manifested. The first one I wanted to show on this screen is the setting expectations. Let me just get the it's setting expectations. So the vehicle, just like Uber, tells me when it's coming, shows me the direction it's coming from, and it even highlights that on an Uber vehicle on the top, I don't know what it is, but it's got a big light thing on the top that circles. When it shows up, it has my initials on the top. So that's a really confirming thing. Oh, this is my vehicle. And the app itself showed me that. It's going to have MW in it. The other cool thing about the confirming aspect of the app itself is it highlighted where I needed to go to get the vehicle. So that was really confirming. It showed me exactly where I needed to be. And also it showed me where the vehicle is coming. So I could see it coming, which was just great. I think this one's going to work. So this is my actual ride in a Waymo vehicle. And I think you'll notice from a lot of my interactions that this is a great demonstration of no UI. I don't have to hardly do anything to interact with the Waymo itself. It recognizes my intention and then does things to help me. Like, for instance, when I walk up to the vehicle and confirm that I'm there, the door handle's open to show me that it's ready for me to enter. I don't think you can see the MW on that top there, but you see how the car noticed I was there and opened up. And I don't know, can you guys hear the audio of the video? There's also all sorts of audio signals in the vehicle itself. It says, "Hello, Mike, we are going to your address. Ready to go? Buckle up." That's all very confirming. It confirms that it knows where I'm going and that it knows me. All I have to do is press the button, put on my seatbelt, and enjoy the ride. And that's pretty much it. There's nothing else I need to do during the ride. I can fall asleep, do whatever I want. If I do have an issue, there were ways for me to summon a real person. There's a button for support. You can pull the car over right away if there's an issue. So I do still have control of the vehicle if I need. But for the most part, it's hands off, and I really don't need to do anything. It did everything for me, and all I needed to do was show up and participate in the experience. And it's really a delightful experience as well, far superior to driving a car or being in an Uber. Okay, so let's talk about some key takeaways, and we're done. Just so you know, thank you for coming. Hopefully this wasn't too condensed. As our UI interfaces evolve, AI interfaces will become less visible. We are not going to still be in the modicum where we have touch interfaces and we're requiring the user to interact a lot. We're going to need to become intuitive and know what the user wants at all times. It's really important to minimize cognitive load for effective AI interactions. I believe that AI is going to drive a lot more interaction, a need for interaction. requiring nuances of detail or driving outcomes in different ways. If we can be successful as designers and minimize the interactions so they're only presented when they are needed, it's going to present a much better UI and experience for our users. It's important to go beyond touchscreens. We need to embrace new modalities like voice. Something that I didn't get too much on is context. The things that we know about the user are now fair game for the user interface. We knew that the lady liked hamburgers, and we used that to present her a good experience. Context is going to become very important for the user interface and very important for serving the user in this no UI way and getting the predictions and understanding the things they want. And finally, strive for no UI whenever possible. We want to use outcomes to present the user with confirmation. We don't want to present the user with more user interface that is just going to create high cognitive load. Okay, I'm sure I don't have time, but please come up and talk to me afterwards with your questions. Please feel free to reach out to me either on my website or on LinkedIn. And again, apologies for being late, but thank you for sticking with me.